Okay, question number 6 is like this. So this is the shaded area here. The shaded area is between the curve and the straight line and also the y-axis. So which one is it? Huh? Okay. Now, when we integrate, you see this area here is curve, between the curve and the x-axis. So we have to integrate y dx, right? This area here. But this area, the shaded in red color, the dotted lines here, is not the required area, right? The required area is this part, right? The required area is this part between the curve and the straight line. Between the curve and the straight line. But when we integrate, we not only find out the area between the curve and the straight line, but also this whole part here. Because it's from the graph until the x-axis here. So this is what the definite integral will give us. So how to find this particular part here? How to find this part here that is needed by the question? Any answer? Do you know how to find this part here?
Don't know, like teacher. I don't know.
Never mind. You just say something wrong, then I will tell you why it's wrong, so that you can learn from your mistake.
Find the not green color part.
We want to find the not green color part.
The area. I think the area under the graph.
Area under the graph. Okay,
the half of the area under the graph minus the green color.
Minus the green color, correct. So the area under the graph is this red dotted line. When you use the dotted line minus the green color, then you will get this part, the remaining part. So this is how we're going to find. But before that, you must also know the coordinates of A and B. Only when you know the coordinates of A and B, then you can know the limit. You want to integrate from where to where. And also, this green color part is a trapezium. So this trapezium, if you know the coordinate of A and B, you will know the length of the sides of this trapezium. So you can find the area of the trapezium. Okay? Right. So before you solve any question of area, you have to solve for the points A and B. Right? So how to find A and B? I write down the two equations. The first equation is y equals to 4x plus 1. This is the straight line, y equal to 4x plus 1. Well, at the point A, the x coordinate is 0 because it is on the y-axis. So the x coordinate is 0. So you substitute in x equals to 0, you will get y equals to 1. So the coordinates of A found 0, 1, right? Then we carry on, want to find the coordinates of B. Okay, so you use this 1, you substitute into equation 2 or whatever lah, 2 into equation 1, right? So when you substitute, you will get 4x plus 1 equals to x squared plus 5. These are the two equations, the equation of the straight line and the equation of the curve. You join them together. So when you join them together, you solve for the value of x. You have a quadratic equation. So when you solve this quadratic equation, you will get points. So factorize this, you get x equals to 2. X square, x minus 2 square equals 0. So x equals to 2. So substitute x equals to 2 into your y here. So 4 plus 5, your y is 9. So the coordinates of B, they are 2 and 9. So any questions so far? Solving the two equations to find the
No.
points of intersection? No.
Uh,
Now, why we should find the point of intersection? Number one, because we want to know the upper and lower limit of the definite integral. Number two, we want to know the sides of the trapezium, right? So to find the shaded area here, the little part here, or just now I show you here, the little part here. So you have to use the area under the curve, right? The pink, the red dotted lines, minus the area of this green trapezium. So it's area under the curve minus the area of the trapezium, right? Area under the curve minus the area under the trapezium. So when you do that, how to get all the numbers substituted there, right? Now the area under the curve, because it's between the curve and the x-axis, so you integrate y dx, right? And the coordinate of B is 2, 9. So you integrate from 0 to 2. From 0 to 2, right? Y dx. 0 to 2 y dx will give you the area. Which area? Yeah, this one. From 0 to 2. Can you see the 2 here? Now the 2 here. From 0 to 2, and you integrate this curve, you integrate this curve, right? This blue curve, from 0 to 2, you will get the whole area here. Okay, that is given by this definite integral here. That's given by this definite integral. Then we want to subtract the area of the green trapezium. Green trapezium, area of trapezium is half AB times H. Half AB times H. Okay, so what is the y? Y is, from the above, y is x squared plus 5. So you replace the y with x squared plus 5, then integrate with respect to x, plus half the sum of the parallel sides. So what is the sum of the parallel sides? This side is how much? This side is 5. The other side is until 9, right? The height is, no, the trapezium is, this one, 1. This side is 1. The other side here is 9. This one is 9. Okay, here is 1 and here is 9. So this height here is 1. The height here is 9. What is the distance between the two parallel sides? The distance between them is 2. So that's how we get this 1 plus 9 times 2. Any question? How to get the definite integral? How to get the trapezium? The specification for the trapezium? No, can follow. Okay, so I'm going to show you another one. Now when you integrate x squared is x cubed over 3. Integrate 5 become 5x. Now this one you have to substitute the two numbers inside, 2 and 0 inside. Now the next one, area of trapezium, or the 2 and 2 cancel, 1 plus 9 is 10. So we use the area under the curve minus the area of trapezium. You will get the required area. So finally you get the area of the shaded area, right? The area that is required is 8 over 3 square unit. Any question?